Hey, let's discuss how we can get to that random star over there, which happens to be 40 quadrillion meters away, or about 400 trillion football fields. We need a rocket. We need an efficient thruster for the rocket. Efficiency being measured in specific impulse or ISP. A rocket with high ISP is more fuel efficient, which is fairly important for our interstellar trip. It also needs to last a long time, as this trip is going to take a long time. Let's begin. Firstly, chemical engines. They usually work using the controlled explosions of fuel and oxidizer. Current ones have an optimal working ISP at 450 seconds. They have lots of problem moving parts, so this could happen. Boom, not optimal for an interstellar trip. Next up, we have the nuclear thermal engine. The optimal ISP of one with a solid core is 950. Gas or liquid cores may go higher, but those are dangerous. These work on nuclear fission. However, they can be really hot, up to the temperature of the sun. Side note, NASA built cute kiwi engines to test back in the space race. They had some real plans to use these for Mars transit missions, but they still had moving parts and are nuclear. So, if improperly handled, boom, this could happen. Next, let's talk about electric propulsion, which tends to have high efficiencies and long life. There are a lot, so here are some highlights. Firstly, the Variable Specific Impulse Magnoplasma Rocket, or VESMR. Its specific impulse with argon is 5,000. They can use all sorts of fuels, by the way. They use microwaves to create and heat plasma, then magnetic fields to accelerate it. Since hot plasma is magnetically confined and does not actually touch the walls, this thruster has the greatest longevity. Next, we have the Magnoplasma Dynamic Thruster. Its top specific impulse is around 6,000. They use the Lorentz force to accelerate plasma and creates really high power. We also have the Hall effect thruster, which is fairly common nowadays. Its top specific impulse is 8,000. They use the Hall effect to accelerate fast-moving ions. This is the same effect your phones use to measure magnetic fields. Finally, the gridded electrostatic ion thruster. It is the very best with specific impulse at 300 or 3000 and claim to be even higher at 100,000. They use electric fields to accelerate charged ions, but the ions colliding with the electrostatic grids significantly reduce thruster lifetime. So it seems that electric propulsion looks good for interstellar travel. But let's not forget about the light sails. These are nice ground stations, likely using the power of a small city. Project Breakthrough Starshot is an ongoing effort to send teeny tiny probes to fly by Alpha Centauri using light sails powered by lasers from Earth. But if you're feeling extra brave and adventurous, we can always turn to the nuclear option, or nuclear pulsed propulsion. Enter Project Orion. It can provide massive thrust in bursts of tens or hundreds of kilonewtons. The piston reduces strain on the space frame. We shall use nukes to push propellant towards a piston pusher plate. Its best specific impulse. It has the best specific impulse with really good material, which is 100,000. This is what it would look like. Flashes of light behind a glorious spacecraft. It can send thousands of tons to orbit, or accelerate a spacecraft to a few percent of the speed of light. There is also Medusa, using a less conventional design. The explosion pushes on the sail, which must be really strong. The tension cables and the triggering arguments the acceleration on the main spacecraft. So really, our options are only limited to electric, nuclear, and light sails. It really depends on what we are looking to do and how much funding we have. Bye. Remember to break on the other side.